Alright, in this next video, I'm going to talk about the lens and how we change the shape of the lens so that we can basically focus on images that are far and near. So you have to change the shape of your lens in order to see near and far. Now, I really am just going to first start by talking about the cornea and the lens. When we talk about light, light's called photons. That's why these are called photoreceptors. The light has to enter the cornea. Now, light bends. That's something we call refraction. So I'm just actually going to draw my light with this yellow marker, but I'm not going to really show it. Well, I'll show it bending a little bit. So light enters the cornea, is going to refract the light. Light has to enter, so it bends the light. Light then has to be bent again when it hits the lens, so that's a refraction. And light literally is going to travel to the fovea centralis, where there's the most photoreceptors. So light has to first enter through the cornea. It has to go through the pupil, so the iris is going to control the shape of the pupil to basically regulate how much light enters the back of the eye. And then the lens is going to bend the light as well. Bending light is called refraction, so that it can go to the area of the fovea centralis where you have the most photoreceptors to help you see near and far. So there is something called refraction disorders. If you have a misshapen cornea or a misshaped lens, the refraction bends it in a funny way, and that's called an astigmatism. So I'll go over conditions, but I'll draw the eye out again. But I want to talk about the lens. Now, the easiest way to think about the lens is to think about the ciliary body as a way to contract and relax, which changes the shape of the suspensory ligaments. However, anytime the ciliary body contracts, the suspensory ligaments relaxes. So right now, this is a very relaxed suspensory ligaments. The easiest way to talk about the ciliary body and the suspensory ligaments is to use an analogy such as a balloon. So I'm going to draw on a piece of paper that we've already used. Alright, when we talk about, let's say this is a balloon. Here's my balloon. I'm going to actually draw it this way. Now, if we said a balloon represents the lens, and the suspensory ligaments is strings that are tied on either side. So if we took strings and say we were in the classroom and we pulled the balloon would basically get skinny. But if the strings were, relaxed, the balloon would stay thick. So if the balloon strings, the strings are the suspensory ligaments. If the suspensory ligaments are relaxed, then basically the balloon is going to stay really thick. So the same thing happens, or not the same thing, something else happens when you pull on the strings. Now, if you pull on the strings, the balloon is going to become skinny. So when you pull on those same strings, when you say the suspensory ligaments are tight, the balloon or the lens becomes skinny. Now, the ciliary body, which is what's attached to the suspensory ligaments, are always going to be opposite than the suspensory ligaments. So if in this one, the suspensory ligaments are relaxed, then the ciliary bodies are going to be contracting. So if the suspensory ligaments are tight, then the ciliary bodies are always going to be relaxed. They're always opposite, and I'd pick one and just kind of learn it that way. Now, when we talk about the actual lens, find that blue marker. We have two different shapes of lens. So the lens can either be nice and thick, this is what we call a convex lens. Or the lens can be long and skinny like this, and this is called a concave lens. So we have two different sizes of lens. Remember, a lens has to change shape to help us focus on near and far. So the picture that I drew here, this is basically a convex lens. This would be the balloon with the suspensory ligaments pulled tight. This is a concave lens. Now, the function of the lens is to change shape to help you see near and far. So, when you have a convex lens, this helps you see near objects. When you have a concave lens, this is going to help you see far or distant objects. Now, using the analogy of the balloon, you can remember always that the suspensory ligaments and the ciliary bodies are going to do opposite. So if you say this is a balloon, what is making the balloon skinny? So you would say the suspensory ligaments, which are the strings attached to the balloon, have to be pulled tight. Now, for the balloon to be nice and plump, the suspensory ligaments have to be relaxed. Now, the ciliary body contracts and relaxes. The ciliary body always does opposite of whatever the suspensory ligaments does. So, if the suspensory ligaments are tight and it makes it a concave lens, then the ciliary body are going to be relaxed. It's always opposite, tight or relaxed. Over here, since these are relaxed, your ciliary bodies have to be contracted. Contract means to contract or pull tight. So this is how we see near and far. Now, most of the time, when you're talking about normal vision, you're not like staring at something really, really close. That would actually really hurt your eyes. So when you're talking about concave lens, this is the kind of lens that we have most of the time. It's you're walking down the street, you're looking off in la la land. That's what we call emotropic vision. Emotropic vision, your ciliary bodies, which is the muscle, you want to be relaxed. This is what you want. If your ciliary bodies are relaxed, then you don't have eye strain. So you're looking off in the far distance. If you contract your eyes, that means you're looking at something close. If you stare at something close to your face all day long, your eyes start to hurt. So you want the ciliary bodies relaxed. This is what we call emotropic vision. In emotropic vision, your ciliary bodies are relaxed, your suspensory ligaments are tight, but your muscle is relaxed. So this is basically what we call normal vision. You're not staring at something, anything close. You're looking at far distant objects. Now you need to be able to change the shape of the lens to see near objects all the time. You see near, you see far. So when you change the shape of the lens far to see near, so say you're looking off at 7-Eleven or DK or whatever it's called now, and then your phone rings, you look at your phone, you have to change the shape of your lens to a convex lens. This is what we call accommodation. The definition of accommodation is basically the ability to change shape of the lens from concave to convex to see near objects or far objects. So I can be walking to 7-Eleven, my phone rings. I use a convex lens, look at my phone. put my phone away, change the shape of my lens, now I'm looking off in the distance again. That is literally accommodation. Now, another type of vision that we talk about, which is not really related to the lens, is called stereoscopic vision. Stereoscopic vision is basically when you look at something near or you look at something far, you can basically have a perception of the distance. You can basically, say this is about 12 feet from my nose. That's stereoscopic vision. Now, as far as the lens goes, the lens has to change shape so that the light can hit the fovea centralis. So when we talk about light, we have to understand that both the cornea and the lens is going to bend light, which is called refraction, to get the light to the fovea centralis. So I want to talk about refraction disorders, and you have to remember light is going to go to the fovea centralis to help you see near and far, but you also have to change the shape of the lens. So when we talk about refraction disorders, this is a disorder where you're going to have to be prescribed convex lens or concave lens to help you fix your eye. So the first type of refraction disorder that I want to talk about is called myopia. So this is a refraction disorder of the eye. A refraction disorder of the eye basically means that when you bend light, it doesn't hit the right area on the fovea centralis. So the first one is called myopia. Myopia is called nearsighted. So when you say that you're nearsighted, basically that means you can see near but you can't see far. So you have to remember during emotropic vision, you're normally looking off to the far distance. So if you're nearsighted, but you're normally looking far and you can't see, that means that your eyeball literally is just like way too long. So you have your cornea, you have your sclera. These are like melon eyeballs. You have long eyeballs. Here's your sclera, and then here's your optic nerve. For myopia, your eyeball is literally too long. Now we know that the cornea and the lens are going to bend the light. So light is going to go through the cornea. It's also going to go through the lens. Now this is a refraction disorder. However, the lens and the cornea can only bend light so far. So if your eyeball is too long, it literally is too long. The cornea and the lens can only refract light so far. So I'm just going to use basically pink. The light gets bent through the cornea and through the lens, but literally it can only bend it to right here. So normally you're looking in a far distant, but your eyeball's too long, so you can't see far. You can only see near because your eyeball's too long. So to fix this disorder, if you're nearsighted, to help you see far, you have to have a convex lens, which is glasses that are going to be prescribed to you in order to fix it. Sorry, concave lens. So your glasses are your corrective lens. So concave lens are going to be what they prescribe to you to help you see far. So if you have this, now they can correct it so that the light can go to the back. Your eyeball's too long with myopia. Now another refraction disorder. This one is more common than nearsighted. No, nearsighted is more common. Y'all got melon eyeballs. So if you have a condition called hyper, remember hyper is always too much. So hyperopia is a condition where you're farsighted. Now remember, most of the time you're looking far anyway, but hyper means too much of something. So this one is opposite of too long. These eyeballs are little short baby eyeballs. So you got short eyeballs like this. I don't know what causes someone to have short eyeballs. I don't know what causes someone to have long eyeballs. I guess it's genetics. So, this one, your eyeball's too short. Now, when you think about the lens and the cornea, it's gonna refract light. Now, everybody's cornea and lens, hopefully, are pretty much the same shape. So, hyperopia, the lens and the cornea do too much of a good job. And when they refract light, the light goes past the fovea centralis. Now, technically, it would stop right here, but it's hyper. Now, they can see far. However, because their eyeball's too short, they can't really see near. So, the corrective lens is because they can see far but not near, is they would need to have a convex lens prescribed to them. So, your glasses would be nice and thick. So the corrective lens would be a convex lens. Now, if you're like me, you don't have melon eyeballs, you don't have marble eyeballs, you just have normal eyeballs. If you have normal eyes, the light should enter through the cornea. Remember, it's a refraction disorder. It'll go through the pupil and then it'll hit the fovea centralis perfectly. Now, over time, you lose the ability to change the shape of the lens. I guess it's just like something that happens with age. So that's another refraction disorder. If you can't accommodate and change the shape of the lens, there's another type of refraction disorder which we call presbyopia. So they're all opia. So presbyopia is basically farsightedness. Now everybody looks far with age. Now, this would be like you have a normal shaped eyeball. So here is my sclera. Here's my lens. The light enters through the cornea. I'm not gonna draw this black because it's gonna bleed through to the other side. But basically, Emotropic Vision, it's always gonna go here. Now, it's farsighted. You see that all the time. When you say presbyopia, this is not a problem basically with the length of the eyeball. The problem is you cannot change shape of the lens. You lose the ability to change the shape of the lens, mostly because you lose the elastic quality of the lens. So one common thing, you know when your parents are going through this, because when you'll say, hey, look, I made an A on my anatomy test, they hold the paper really far. Instead of like holding it right close to their face, they are looking over their glasses and they're holding it arm's distance away. That's presbyopia. So we have three types of refraction disorders that I've talked about so far. Myopia, your eyeball's too long, it looks like a melon. So basically you can't see far because normally it goes all the way to the back. So you're nearsighted, but it doesn't go to the fovea centralis. Hyperopia, it's too short, so you can see far, but you can't see near. And then presbyopia is whenever you lose the ability to change shape of the lens. Now, another refraction disorder is called astigmatism. Astigmatism is when you have a defective curvature of the cornea or lens. So when you have a defective curvature of the cornea or lens, you have an astigmatism. And so maybe you can see near and you can see far, but a little portion of what you're seeing is a little bit blurry. So astigmatism technically is a defective curvature, which makes it a refractive disorder. Now, I want to go through a couple other conditions of the eye, which you should definitely understand. So I'm going to draw an eye really quickly. So if you want to push pause, basically I'm going to draw the eye out how we drew it in the beginning. So we have the cornea, allows light to pass. I have the sclera, the optic nerve, which helps you see. The next layer is the middle vascular layer. You should draw your choroid coat. I like the color maroon because it helps remember its blood vessels as well as melanocytes, which is brown. And when you mix brown and red, it's maroon. The ciliary bodies, which are smooth muscles, which are going to control the shape of the lens with the suspensory ligaments. Remember, they're always opposite. So the lens is going to be suspended in the air. Suspensory ligaments with the ciliary bodies are going to control the shape of the lens. And then we had our iris, which is going to have muscles, which are going to control the shape of the pupil and regulate how much light enters the back of the eye. So there's your pupil. Then we had our retina, which is our neural layer that has photoreceptors, rods and cones. However, there are no photoreceptors in front of the optic nerve. So that's called the optic disc. So you can literally draw your optic disc there. On the retina, we have a yellow spot in the back of the retina. Yellow spot, this word for spot is macula, lutea is yellow. In the center of it is a pit called the fovea centralis. So here we have the ora serrata, which is basically just the boundary between the front of the eye and the back of the eye. And then we had the posterior cavity, which is anything behind the lens, which is going to be filled with vitreous humor to keep the retina against the choroid coat, and then your anterior cavity. So, refraction disorders include astigmatism, and then if your eyeball's too long, myopia, if it's too short, hyperopia, and if you lose the ability to change the shape of the lens, that's called presbyopia. If you have a defective curvature in the cornea or the lens, that's astigmatism. So I'm going to cover a couple of more conditions. Now, if your lens becomes cloudy, it usually makes a yellowish gray color. If the lens becomes cloudy, I'm not going to use yellow. I'm going to use a gray because literally, if your lens becomes cloudy, you can't see past it. So literally, when your lens becomes cloudy, this is a condition known as cataracts. Cataracts is when the lens becomes cloudy. Now, if your macula lutea starts to degenerate, so I'm going to put an X through it, this would be called macular degeneration. If you have macular degeneration, you start to go blind because this is where your fovea centralis is. Remember, this is the macula lutea. So when you have macular degeneration, you lose the fovea centralis and you start to lose vision. Now, if you are missing rods and cones, if you have a genetic disorder where you're lacking cones, that is literally called color blindness. Color blindness is literally where you're missing cones, which helps you with color vision. Most common is red and followed by green, and you'd use Ishihara plates. So for each one of these, basically so far that we've drawn, we can basically talk about them. Cataracts basically is when you have a cloudy lens. It's going to help it's going to impair your vision. Macular degeneration. Macular degeneration means that you degenerate the the macula lutea with the fovea centralis. So literally you're going blind. Okay, color blindness. That's on the retina. You're missing, or genetic defect would probably be better. Missing or genetic defect in your cones, especially with red and green. So you'd use Ishihara plates. So we've talked about myopia, hyperopia, presbyopia, astigmatism, cataracts, macular degeneration, color blindness, and then when you have too much aqueous humor in your anterior cavity, this would be called glaucoma. You have too much aqueous humor in the anterior cavity, either because it's not draining or you're producing too much, which can also lead to blindness. Now, if your posterior cavity, you lose vitreous humor, you'll have retinal detachment, which is also blindness. So, the posterior cavity as well as the anterior cavity is just as important. So, I try to go over all the conditions and the parts of the eye. This basically is just going to cover non-refraction disorders, and then I covered the refraction disorders whenever I covered the cornea and the bending of light refraction as it goes to the fovea centralis.